this talk is about the different components of Samba that storage or application integrators can utilize. And what can we do for storage vendors? We can just be the component that creates a computer account in Active Directory, very small piece, and that gets your key tab. And up to we can be full clustered SMB on top of your clustered file system. 4 sections in this talk. Quick overview of the architecture, what we are. Then I will have some slides on difficulties that we have to face and our expectations from anybody implementing a file system and where bottlenecks and potential problems from the field are. Then I'll talk about Winbind. This is a summary of the talk that I gave last year about authentication and authorization. And then about RPC services, what can we do for it? Why is this an issue? And what can we do for you there? Okay, I am Volker Lendecke. I come from Germany, Göttingen. I work on Samba for quite a while now, and I mainly see my role in maintaining our infrastructure, also Winbind, Clustered Samba. Clustered Samba was invented together with Tridge by me. And if you are interested, if anybody would be interested in writing an Active Directory domain controller or providing one, talk to my colleague Stefan Metzmacher. He is really, really deep into the protocols of Active Directory. Okay, by the way, this Active Directory multi-master replication was his bachelor thesis even before it was documented, so he knows this stuff. Okay, what is Samba? According to Samba.org, it's the standard Windows interop suite of programs for Linux and Unix. And Windows interoperability, as you probably have figured out, is pretty rich. Large range of protocols. We have DNS. We used to have NetBIOS. That's long ago. Nobody uses NetBIOS these days anymore. We have a whole range of authentication protocols. Everybody tries to move to Kerberos, but most installations I see still kind of depend on NTLM. One of the problems with Kerberos is not the timing issue. You have to have exact clocks, precise clocks, up to like a few minutes, and that's mostly solved. It's naming servers. So if you connect to an IP address coming from a client, no Kerberos anymore, and that's a problem. Then we have LDAP and RPC. We have SMB, the base file sharing protocol, and we have remote procedure calls. And this has to be implemented by normal file servers as well. And I'll tell you why. Samba is GPLv3+ for most pieces. This means that if you really want to link, then your code is also GPLv3+. That's the requirement of the GPL. But there are components that I'm going to talk about that can be used independently without GPL requirement. Samba components. As an SMB server, we are a multi-process daemon, talking to the file system, exporting POSIX semantics as Windows semantics to the client. Essentially, we map from POSIX to NTFS semantics. We have a flexible VFS, so all operations that go into the Linux kernel or Unix kernel to the file system go via a pluggable interface, and you can intercept this. And for example, if you look at the Ceph implementation that we ship, there is no direct POSIX interface. They use a library to talk to the Ceph storage cloud. Then we implement RPC servers. We are definitely far away from being complete here. We just do what, we have the full documentation on all calls, on our RPC interfaces, but we only do what the Windows client would expect, because RPC is a huge amount of work. And as I said, we are an Active Directory domain controller. We do LDAP, we do Kerberos DNS, and more RPC interfaces required for AD. From the client perspective, we have utilities to join Active Directory, to query the Active Directory user database, and so on via native Windows interfaces. We have the registry and so on. and joining an Active Directory, essentially creating a machine account, in some environments can be surprisingly complex. And this is, for example, one of the pieces that we could do for you with a simple net command. You get a computer account in Active Directory, and we get you the key tab with a service principal key. One step further, Winbind is our component that talks to Active Directory for authentication and local user creation. So concept of Windows domain membership is all AD users are available local, and this is what Winbind does for you in a Unix environment. Okay, you have implemented a fancy new cloud accessing cluster file system, and you want to export this via SMB. What is required? There's certain aspects I want to talk about. Access control, what do you have to expect here? Then logging, what do we do for you and what do we expect from your side? Case sensitivity, that's mainly a performance issue because Windows file names are case insensitive, or they expect on the wire to be case insensitive. POSIX typically is case sensitive. And then some minor topics like, how do you delete a file? There is no unlink call, and we have to take care of that. So access control. User logs into your box, or via SMB, or SMBD, or whatever. And what the domain controller tells you is user ID and list of group IDs in a format that Windows defines, namely security identifiers. And security identifiers are essentially 128-bit UIDs, NGIDs. And on Linux, typically you only have 32-bit. Also, most file systems in the Linux world just stores 32-bit identities for access control. And Winbind then has the task to somehow map this 128-bit user ID space into 32-bit. And it can be done in a few different ways. Our default way is right now TDB. I didn't mention it here. What we would like to be is idmapping. What this means is, autorit, sorry. What it means is Winbind invents local Unix IDs coming in from, so an Active Directory set comes in and we have to invent a local Unix ID, and Winbind invents a range of IDs locally and stores this in a static table that you have to, of course, back up. This is per host. Our default is still a different one that is very inefficient. It's essentially the previous version of idmap autorit called idmap TDB that's much less efficient. So we made that more efficient. Autorit is per host. So if you have a clustered version or if you have multiple independent Sambas accessing your file space, you have to take care of this. You have to distribute this mapping because one user should always be the same Unix ID independent of where you connect to. So this idmap autorit is always per host doing this. And this creates problems if you have multiple machines. For that, to get rid of these problems, you could use the idmapping. This requires that you manually configure all your hosts with static mappings. You could also use idmap AD, and this requires that the Active Directory administrator maintains the Unix IDs in Active Directory. We can just query that. And this will be the same for everybody. And yeah, so the options. And we have idmap script for some weird configurations where you have to access some external database. We can call out to a script that can then connect to your HR database or to whatever. Then we have, so we are connected, we have Unix IDs. Then you want to access your local files. And typically the normal POSIX file system just has user group others, read, write, execute. That's not what Windows clients expect. We do some simplistic mapping, but it's of course lossy. You have a very, very rich ACL model in NTFS. And you will have unhappy clients if you don't do proper mapping here. It's possible, and for read-only shares, for whatever, if you have to just export scientific data, you don't really care possibly. You can do that. But if you want to be a good Windows file server equivalent, you have to do NFS-v4 ACLs. FreeBSD has them. Linux has them only on the proprietary file system GPFS. But if you are a storage vendor with a file system on your own, please do NFS-v4 ACLs or whatever is close enough to that, so that you can get good ACLs, a good ACL experience to your clients. If you don't have anything of that, we can store them on our own, but this will then break interoperability with your NFS and Linux clients. So options there. Locking. SMB locking is different from what people know from the POSIX world. We have mandatory locking all over the place, meaning if you want to lock a byte range, the read and writes are actually locked, which is not the case in POSIX. We have per open exclusive access with share modes, and this is what we do for you. So we maintain our own database with share modes and byte range locks, and wherever it's possible, we try to map these byte range locks, share modes, whatever, into what POSIX provides. And if you, for example, have an advanced NFS 4.2 server that does proper delegations and share reservations and so on, we would have to kind of talk about the API between those two. Right now we depend on what Linux provides, and this is very lossy. So the semantics that Linux provides is not very good here. And if you have your own implementation of NFS-v4, doing most of these in the full NFS-v4 flavor, we can talk. We can talk to map them and do them vice versa. Same with leases and oplogs. SMB provides a good cache coherency protocol, and we do that if you're exclusive SMB. We don't do directory oplogs yet, directory leases, but everything else is done. If you want that to coordinate with NFS or local access, it's lossy. We can't, for example, do read oplogs, level 2 oplogs when you enable Linux kernel oplogs, but just because we don't have any APIs to talk to. And we need them eventually. So, other bits and pieces. Case sensitivity. Take away from this. For fshook get real file name, get us a case insensitive indexed search on directories. That's the major take. And I could talk about for this for a while. Case insensitivity for us is expensive. Get us an indexed search for uppercase, lowercase, agnostic. And we have a hook for this, get real file name, asked for uppercase, lowercase combination X, and you tell us, yes, I found this, but with this different uppercase, lowercase. This will really boost up your performance. Directory traversals, query directory it's called in SMB. This is essentially a read dir +++. The client can specify what kind of detail they want. In Unix, this means that we have to manually get a lot of metadata from a file, stats and getExator, a lot of them. So you can hook into our VFS read dir and just cache the information in advance and so on. However your implementation looks like down below, we need this to be fast. And then delete semantics. This is kind of weird. How does Windows delete a file? They don't call unlink because there is no unlink. They open a file, they ask for delete permission, they set a flag, and when they close the last handle of this, file is gone. The problem here is that the user message, I press delete on a file in a Windows Explorer, the access control is only on the open. And we can't just try to delete a file to see whether we are allowed to, because afterwards the client could just not really ask for the flag to really delete the file. This means we have to do access controls in user space. And if you want to go really advanced, give us a call that opens a file and extends the permission bits that we ask for. And in particular, this delete thing is important here. So we want to ask you, hey, we want to open this file, and we later want to delete it. This doesn't really match the Linux VFS with inodes and directories, but it's something that Windows does, and which requires us to do all access checks in user space, which can be slow, but that's what you get when you want a full-blown SMB experience. So that's SMBD. Now you have your own implementation of SMB, and you don't want to mess with NTLM, Kerberos, Windows domain controllers, and so on. Let's talk about authentication, authorization. Authentication, user is identified correctly. Authorization, what groups is the user member of? Essentially, that's it. Who provides this information? For a home NAS box, it can be used local passwords. Typical deployments are all Active Directory these days. What is Active Directory? Essentially, it's a KDC with a big LDAP database with a very special schema, lots of internal magic to maintain internal consistency. One thing to keep in mind is that contrary to normal Unix deployments of Kerberos, inter-realm, cross-realm trusts are really popular and common. So in the normal university setting, typically you only have 1 or 2 realms, all in one realm. Windows domains are a lot more complex. And to be honest, probably you don't want to deal with this. How does Kerberos and NTLM down below work? We have to trust the domain controller to be the correct machine to tell us, yes, Volker Lendecke is actually domain administrator. And this trust is established with a workstation account that carries a password. And setting up this password is joining an Active Directory, called joining an Active Directory. And this can use Microsoft RPC. I'll get to that in a bit. It can use LDAP. And what we have is a netADS join command that does all you need. It looks up a domain controller. It creates an account. It sets a password. It creates a local key tab if you want to. You can configure it to do so. And you're done. So you don't have to deal with this piece. And this is just a utility. Okay, it's GPL. If you want extensions to that utility, they are GPL. But typically, that's enough. That should typically work well. Then Winbind. Winbind is the utility that maintains live connections to domain controllers. It sets up a secure channel, a trusted channel based on the workstation account. It looks up domain controllers. It establishes this encrypted channel. It changes its password weekly so that policies in Active Directory cannot throw you out. You need to change passwords weekly or monthly at least. We have an interface that you can easily connect to. We have a library. Look at the last bullet point here. We have a library that is LGPL'd, that is very simple to use. You can just issue calls. Hey, I have user password. Please Winbind, talk to the domain controller and tell me if it's right. Please also give me the SIDs. Please do all this business that I talked about a few slides ago with ID mapping. I have this SID now. Please give me a UID and so on. You can easily use this libwb client in your implementation. No GPL obligations, nothing. And this will take care of all the traffic that is required to securely authenticate against Active Directory. If you're authenticating with Kerberos, Winbind also has an interface to dissect the what is from the pack. Essentially, in the Kerberos ticket, you get all the group information as part of the Kerberos ticket, which is Microsoft NDR encoded and somehow signed. You don't want to implement this, talk to Winbind. We will dissect this for you. Okay, that's Winbind. You have your cool and new SMB 2 or 3 or whatever implementation. And how hard can it be just to implement 19 protocol elements? It can be hard, but it's not enough. If you then, so basic open, read, close, read, write, close is not too much work. It is doable in a few weeks, possibly from scratch. But then Windows connects, and you see this. What is this? It's the netshare enum server service pipe that Windows uses to list shares. Holy crap. I just connect to that server and it gives me nothing because I don't have RPC. And that's the world of Windows interoperability. To get a seamless experience, it's not enough to just have SMB. You need to have all that Windows provides, or I mean, the parts that we implement. SMB is just a tiny part of the full Windows client experience. What is this? It's DC RPC. Does anybody know when DC RPC was invented? 80s, early 80s, I don't know. So it's when remote procedure calls were really the latest thing, and latest and greatest thing. There was ONC from Sun, ONC RPC, and then there was DC RPC. Maybe there were a few more. There was Corba or whatever. And from that era, we have distributed computing environment remote procedure calls. You don't want to go there, trust me. You don't want to do that. If you do that correctly, we have really decades of experience doing that. However, Windows expects this for a simple task like listing shares of a server. And this is where we can help you. Samba's RPC implementation, we have servers and clients for all the important protocols. And if you look at our current implementation, we are currently, somebody from the Samba team, Samuel Cabrero, is right now reworking this. We are not implementing the protocols the right way. This is right now all linked into SMBD or the Samba binary. This is pretty easy to implement. And in 2010, Simo Sorcher started to split out the printing daemon. In Windows, printing is also done over RPC. And this is the foundation to really do RPC the right way, namely completely split the transport, which is SMB named pipes, or TCP, which we don't have to deal with ourselves, but which is SMB named pipes from the implementation of RPC. So named pipes is a business that SMBD has to take care of. RPC is another binary. And with some simple patches, you can just split SMBD or trim SMBD down into a daemon that just does this server service interface. You look at frame, look at this frame above here. It's what is server service? Essentially, Windows clients open a file on a special share. Your implementation then will have to map this opening of a file into a connect call to a Unix domain socket that we provide. And you will then direct all read and write requests. This is a write request, read request. You will direct this into, you will just map this into normal read-write calls to this socket, and we do all the other business for you. And this is the way we want to implement it. And looking at the current progress, I would say it's very likely that we get there this year. I'm not saying when, but we will get there this year, I guess. So right now, you have to have some modifications that are pretty simple to strip down SMBD. In the near future, we will have that as a normal implementation and of RPC services. And also, this Unix domain stream socket is a GPL boundary. So you have your SMB implementation, you can talk to us, no GPL requirements. If you want other services, if you want to tell us what your share listing actually is, we need to talk. This is probably GPL, but I mean, listing shares should not be your core IP. And this is something that some protocols should be able to deliver. Thank you for your attention.